everyone once again. So today, how to download Visual Studio Code. So just go to any browser of your choice. So in this case, I'll be using my Edge, my Microsoft Edge. So you can use anyone. You can use Google Chrome, but I prefer Microsoft Edge. So you want to do Visual Studio. You can just write Visual Code download. You can just write VS Code download. So it will take you to somewhere like this. So you can see we have the AI search here. So you want to go to the official link, which is you can see visualstudio.microsoft.com here. So let's click on this one. So let me close this. Enter picture in picture automatically so you can see it. Okay, now this time. Okay, good. Um, I'm so sorry I was logged out. So now let's continue. So after you are done here, you see something like this. So because I'm using a Windows computer, you want to look at where you can download yours. So you can actually download it here. You have our free download. So it is asking for the Windows computer here. So you want to check anyone. Which one are you using? Are you using MacBook or using Linux operating software. But because I'm actually using Windows X64, my own computer can download this. So I will just click on this installer. Then once I click on this one, it will start downloading. But because I have that already, then after it is done, after you are done downloading, you'll see something like this. So let me just go there. So you can see we have something like this. When you are done downloading, then you click on this one, then you click on next, then install. So I'll send a what do you call it? I'll send a YouTube link on how to direct us how to download VS Code. So what's the importance of this VS Code, or what's the significance of this VS Code? Now let's just look at it and let's see what it can do. Please, can someone confirm they can hear me?
Yes, we can hear you, sir.
Okay, good. This one is not disturbing us. Okay, so it looks like this. Majorly, we use this VS Code. It is common among the engineer, the software engineer, and the front-end, back-end engineer. So we use this VS Code to create a web app, basically. And remember, we've written a lot of codes. We've written the diabetes prediction system machine. We've written the breast cancer, and personally, I hope that we have um, we have practiced beyond what we have been taught in this particular training session. We have practiced beyond that. So we have the editor here. So we have our editor here. So let me just click on this one. So we have our editor here. So most of these things we will not be using it because we are not doing front end, right? We just use where we are writing the code, and basically that's it. So we have how to navigate our stuff here. So we have let me just put it three. So we have our editor here. Mhm. So this is where our terminal is. This is where we see the result of the output of what we are writing. Then we actually don't use this. I think this is for AI. Yeah, this with AI. So we really don't use that one that much. But most especially we use this one. But don't worry, as soon as you start, you understand the interface better. So and also I think we are all conversant with Anaconda also. So let me just click on Anaconda so we can see how it looks like. So instead of downloading VS Code, there is actually inbuilt VS Code with Anaconda. So I'm waiting for it to come up. Hasn't taken that long. It's loading. Okay. So um there are built-in IDs with Anaconda Navigator. There are a lot of them. So I will show us now. Let this just give me some minute. Let this come up. So remember, we have been using Google Colab. So whatever Google Colab can do, we have our Jupyter Notebook here. That means Jupyter Notebook can do it, and we have several IDs that can do it. Once this is launched, we will see a lot of IDs that are present inside this. Okay, I guess we need to do other things while it load, because it's taking too long, honestly. Okay, so maybe while it is taking too long to load, I want to inform us about an initiative we are ISDA intends to do. So in January, right? Obviously, we'll be done with this training session. In January, we will be hosting a build your portfolio with me. So you would ask me, what does that mean? So remember, most of the stuff we've done here, we've done a couple of projects, right? We've done the ID, and we've done the exploratory data analysis, we've done the breast cancer, we've done diabetes prediction system, and probably we might do two or more before we'll close. And that's like five projects already before. And you can all put that in your portfolio, then that's a that is solid portfolio. So in January, there will be a free, it is free and it is not only exclusive to Exeter Hub students. It is not exclusive to Exeter Hub students. It is for everyone. So there will be some pre-recorded video that will be sending you the links. So the links will be for what will be inside the link will be projects pre-recorded video that we've done. Now let's say you are ending this particular training session with five projects. So in January, we'll be sending pre-recorded video maybe every week to maybe data science. Let's focus on data science now. So we'll be sending pre-recorded video. So this in this pre-recorded video, there will be a lot of projects inside. So let's say we have five projects already. Let's say we have 4 or 5 weeks in January. What I mean by 4 or 5 week, that is 4 or 5 weekends in January. So sometimes it might be four, sometimes it might be 5 weekends. So let's say we have 4 or 5 weekends in January. So let's say we are sending each a link each week. So that will be another five added projects in January. So when you add everything together, that will be 10. So in case you are not here before, maybe you are not consistent with doing these projects, you are not following this training session projects, that means you only have five, which is not good enough, and which is why we advise you to make the most out of this training session. Okay, I guess that's loaded now. So now let's look at it. So we can see we have a lot of IDE. So one of the some of the IDEs, you have the PyCharm here. We have the Lab, we have the Jupyter Notebook. I know a lot of us are conversant with Jupyter Notebook and VS Code, most especially. I think I just explained what a VS Code looked like the other time. So Spider and VS Code, we most of the time we use them to build web app. So it is either we use Spider, sometimes they use PyCharm too, but I love using VS Code and Spider. But yeah, you can use PyCharm also build your um to build a web app. But most especially they use VS Code and Spider. So we have a lot. We have R Studio. So in case you've heard about R, most especially they usually say Python and R. So this is the R Studio here. So once you have this an Anaconda Navigator, it's just like you have a lot of add-ons, and these add-ons comes with a lot of IDE. So you can see we have there are some things I've never used, like this Orange, I've never used it. This Python anyway, I've never used it. Even this Oracle, as big as it is, I've never used it. Doesn't mean I cannot work confidently with PyCharm, Notebook, VS Code, Spider, those are just the things I'm working with and in line with my job. So I want you to download this tool. And also, I think we should all be conversant with Google Colab already. So in case you cannot download this Anaconda Navigator, you can also use the web application that is the Google Colab repository, which is very, very good. Okay, so today we just log into our Google Colab, then we will refresh on whatever we have done because already we had 1 week break. So after that, tomorrow we will start our deployments. Actually, I could have done my deploying video today, but I still need to set up my computer, right? So once I set up my computer, obviously you can see most of these download are today. So let's check. So there are some stuff that will not allow the deployed version model to work. So you can see everything is just done today. So I need to perfect it before tomorrow so we can have our um deploy first web app built by us. So let's look at uh, so Google Colab. Um, okay, it may even recognize me. I think it does. Am I gonna? So where is all my I don't do like this. Okay, I think this it's was it breast cancer? Okay. So now let's just revise on what we've done here. Okay. Okay. So we are just after we are done revising, right? So we will be ending the class. Then tomorrow we will we start our deployment. Basically, we start with this breast cancer prediction machine. But I want to carry everyone along. So tomorrow, when we start our deployment, we won't have any back and forth because everyone already understand. Please just give me a minute. Okay. Okay. So the first thing we did here was importing the right libraries. So by now, I guess we should know the right libraries we need and why we need them. So we have import pandas as PD, obviously, because we need pandas for exploratory data analysis, and also for the calculation aspect of this analysis, we need our NumPy. Then Matplotlib and Seaborn, we need them for our data visualization. Unfortunately, we did not carry them out, but I think we have done that while doing this in this training session. So also we have our sklearn. Now, after you are done exploring your data, obviously the data is clean and stuff, but remember you are trying to do a machine learning model. Machine learning cannot understand English words. English alphabet. So you need to change them to numbers, which is why we have this label encoder. Label encoder try to give a number to the categorical data in your data sets. So we have this standard scalar. So this what we are using this standard scalar for is for scaling. So when we have a lot of inconsistency. When I say a lot of inconsistency, probably a colon has 1,000, 2,000. Obviously, let's say we are talking about, or the column is focusing on the amount. Obviously, you will see something like 1,000, 10,000, maybe in naira, maybe in dollar, whatever currency. So you already know that that will have a large number. But when we are talking about, when we have another column focusing on the age, we have something like 2486. So the difference between 10,000 of the amount column is large, is the difference is very, very, very obvious when we compare it to the age, right? So there is a lot of skewed graph when you plot it, because the column, the 1,000 column will be up here while the age column will be down here. So we need to scale them to be okay. If you are one, let the age column be 0.001, right? In as much they are still binary numbers, because computer actually communicates better in binary numbers. So basically that's why we are using this standard for scaling, right? I think we understand that. That's why we are using this standard scalar for scaling. Now, after we are done pre-processing, we've converted all our text data type into normal data type, into of numerical data type, right? The data set is ready for it to be imported into our machine learning model. So we have to split them. We are not training our machine learning model with everything. We have to train it with some, then test it with some. So it's more like exam. When you understand, teacher will come to your class, teach you a lot of stuff. In the exam, it will bring he or she will bring out a new thing, because he expects you to use the understanding of the concepts to answer the exam. So basically, that's what we are trying to do. We're trying to train the computer with some, then test it with some. So then after what's machine learning are we testing it? We have different type of machine learning, as I've explained in our last class. So we have logistic regression, we have linear regression. So I know I've mentioned a lot, but can someone just unmute their mic and just everyone, okay, let's everyone unmute their mic and just tell me a machine learning model that you know. So who is going first?
We have decision tree, sir.
Okay, decision tree,
Decision
that's
tree.
number one. Thank you so
We have
much. Decision.
SVM.
No, just one. Let everyone has to talk. Mr. Muhyiddin, uh, another machine learning model that you know, is it there? Okay, I guess he's not with us. Mr. Ahmed, another decision tree that you know.
We have the sky kit learning.
No, no, no,
That
that's
one.
not correct. That's not correct. So, okay, let's move the question to Mr. Abbas. So, can you tell us any machine learning model that you know, Mr. Abbas?
Logistic regression.
Yeah, that's already written here. So another one.
SVM.
Uh, So can you tell us the full meaning of SVM?
Uh, uh,
Thank you.
support vector machine.
Oh, that's good. That's good. Miss Sophia. I'm sorry, Miss Sophia. Miss Adesola Rofia. Can you tell us any machine learning model that you know?
Random forest.
Oh, thank you so much. That's actually correct. So, Mr. Muhyiddin, are you back?
Yes, I'm back.
Okay, great. Okay, can you tell us any machine learning model that you know?
AlgaBoost.
Oh, thank you so much. Mr. Mr. Ahmed, do you want to give it one more time? Okay, so we have quite a lot of machine learning model. We have the RGBoost, we have the decision tree, we have the SVM, we have KNN, that's k nearest neighbor. We have the logistic regression, we have linear regression, we have quite a lot, right? We have quite a lot. We have decision tree, we have random forest tree, we have, and if you want to know, just right, there are a lot, sha. So after you're done importing your stuff, your model, your data set into your model, into your machine learning model, please can Mr. Temitope mute your mic, please. Okay, thank you. You are yet to mute it though. So after you are done training the data set, so obviously you want to know how good your machine learning model is. So you want to know the accuracy score, right? So that's why we are importing that. Obviously, the first thing is we need to import our data. So we got some information about our data by pressing df.info. Then we had this one is just to confirm how many null value are here. So you can see we have no null value. Everything is what 0, 0, 0, 0. So we can see from here that df dot is null, then sum, that is sum all the null value, and we can see we don't have any null value there. So which is quite good. So we got the shape, and this is actually a very, very small data set. We have the 569 rows and the 3 columns. So these are all the columns here, right? So we did some data cleaning. We can see we have I think we removed this. Probably this stuff might not be here, but we did remove it. So we have diagnosis unique. So this actually there's something we call targets target data sets and X data types or training data sets. So what do we call it again? Um, I know they call the y axis y colon targets. I think the X is I can't
Features.
remember. Oh, features. Thank you so much. So we have the features and the targets. So what do we mean by feature? Feature. The feature is let's say we want to know if someone is rich. So I can describe the person like this. I can say the person is gentle looking, short, round, with a receding hairline. Usually he wears a skimpy clothes. Those are the description. So the final decision is whether he's rich or not. So you want to add the ending. Maybe okay, I can say the person is round, bold, he wears skimpy clothes, and is of middle age. He is light skinned, you understand? Then I want to say he is poor. So the conclusion is that he is poor. So that is the target. The poor is the target, but all the description I've made earlier are the features. So you can see all of these things now because we are working with a breast cancer. So we've done all the tests, but we want to know, okay, this person has type of data, this type of cancer, yes or no. So you can see we have our diagnosis here. So it is either you have a malignant breast cancer or you have a benign breast cancer, which I've told us earlier. So we can see we have malignant and benign, and I think we did, and we have benign, which is the cancerous breast, having 357. Then malignant, non-cancerous breast, and we have 212 patients that have non-cancerous breast, while a lot of our patients has cancerous breast. So after we are done, I think you can see we have our this how do you call it? This alphabetical test, right? These alphabetical letters. So obviously our machine learning model cannot understand this. So we need to convert it to numbers. So which is why we call our label encoder. Remember, we've imported our label encoder the other time. So we call onto our label encoder, then we try to fit in on this particular diagnosis column that has these alphabetical letters. You understand? So we call on that and we actually change it to 1 and 0, that is M, right? I'm trying to check if I'm correct. So we have our M and B. So now this M being represented by 1, while B is being represented by what? By 0. So basically, that's what we did here. So we got our info now, and we can see everything is now the data type now is either it is integer or float, and we all know that this integer is whole number, while float means decimal number. That means everything now is numerical data type, which is what we need. That means we are done with our pre-processing. So the next thing is we are trying to remove the columns that we don't need. So we can see I've always told us that we need to remove ID unless it is stated that we should not remove the IDs. So we want to remove the ID because it is of no use to us analytically. So after then, I think we remove this unnamed 32 also because there is actually no value there. Can you see it is just zero? So why do we need to keep it? So that's why we removed it also. So and now we have 30 columns. It was 32 before. We removed the unnamed 32 and we removed the ID column. So after then, we separated them into X and Y. I guess by now we should all understand why we are separating them into X and Y. X representing the features, sorry, Y representing the target column. So we can see we said something like df.drop column, that is in this data frame, don't drop everything, but drop only one column. What is that column? That's only the outcome. But in this way, we are only calling one column, and which is what the column that we dropped, which is called what df.outcome, which is great. So now that we've splitted our data set into training data set and testing data set, the next I'm sorry, now that we've split it into features and targets, the next thing is that we need to uh, the next thing is that we need to split them into what into training data set and what and test data set. And obviously we need to do that for both x data and y data. So we call on to x train and x test, that is separate this one into X training data set, X test data set. The same thing for our Y training data set and Y test data sets. Then we did something like train test split, which is what we imported the other time. So this X that is split it into two. Then this Y split it into two. Then this test is meaning that okay, if all the data set is one, if all the data set is one, the testing data set should only be 20%. If testing data set is 20%, who can tell me how many percent will be training data sets? Anyone?
80%.
30%. Okay. So yeah, 80%. Sorry, I need to attend to my mom. And that's very, very important. Okay, so random state. This random state is just like whatever I get as my answer. So if I actually remove this random state, I think I will show us I cannot show you the importance today because if I actually change this row, I might have problem in this particular data set because I need to upload my breast data set here. The breast cancer data set obviously, but currently I don't have it because this is a new laptop, right? So I don't have the data set in this laptop already. So when I reload it, it will show an error. So let's just continue. So this random state is just like whatever I get because you want to replicate what I'm doing, whatever I get, so you guys will get it. So it will not be a random value. So because it is a model, you can get a random value like that. So we are trying to look at number, how many stuff are in our extinct data sets. So we can see we have 455 for our extending data set. That's 455. We are tuning them with 455. Then we have 114 rows to test it. So now we are done with our training data set and stuff. So we want to introduce it to our machine learning model. The machine learning model that we are calling in this case is logistic regression. And I've told us that we have more than just one. So it depends on which one works better, which one work better and the best that we need to use. So in this case, let's use logistic regression. So when I fit it into my X training dataset and Y training dataset, obviously I need to train my dataset, and I'm not using all the old datasets, but my training dataset, which are the X train and the Y train. So I fit it into my model. What's my model? My model is what? Logistic regression. So after I'm done fitting it, then I call on to my accuracy score. How accurate is my stuff? So I got 91%. That means if I asked my model 1900 question, it will get 91.2 right. Then it will get 91.2 right. Then it will get 7.8 wrong. Right. So obviously you need to improve it, right? You need to improve the accuracy of the stuff. But yeah, in this case, we are trying to just call on to our model. So we have our model dot score. So now on my testing data set, the data set it has never seen before is getting 95.6 right. That means if I asked 100 if I ask this thing to predict 100 cases, it will get 95.6 right, which is very good. The probability of missing something is very low. So now I tested it. So what I just did here is I copied the rows of the of my data. Then I converted it into numpy array. So which is, and you remember we imported our numpy array, so which is very, very important. So I converted this thing into a numpy array. So you ask me, why do I need to convert it to a numpy array? Because you are trying to calculate something, and which is why I was calculating it. I was changing it to numpy array. So now I'm changing it to return only one answer. That is, it just one column, one row. So that's what one minus one really mean. So report only one answer. So it is either it is zero, that is, it is either it is zero or one. Might mean zero will mean non malignant, sorry. Zero mean malignant, while one means benign. And I don't want a lot of answer. I just need an answer. So then I did my model that predicts reshape. So this is my reshape here. So I just added this one as an extra thing. So it actually gave me answer that day, but I think there's an error here. So yeah, it gave me an answer that day. So it is giving me that X has 30 features. So what does it mean? Logistic regression is expecting 31 features input. So that's the error. So if I actually want to correct this thing now, so that means these numbers that I've imputed, they are 30, and it is expecting 31 features. Probably when I was trying this thing, when I was doing this project, we had 32 projects initially. Probably I had only deleted one column, but when I was reworking on it, maybe I had deleted two columns. So now when I copied everything, it's now giving me 30 columns, which is not what it is expecting. Which is what So to correct this one, I'll just look at what have I deleted. So then I will add that particular feature in my stuff, then I will get my answer. That's how to debug this thing. So do we all understand this particular project before we move on? Please, can you reply with an emoji if you do understand everything that is going on here? Only one person. Slow now. Okay. Great. So this is where we end the class. Tomorrow we start with our deployments. Please, let's be present tomorrow. It is very important that we are present because it is technical. It's a bit technical. It's something we have not done before, and I actually appreciate today's attendance because yeah, it is very impressive. So let's keep it up tomorrow and let's try to be punctual to class tomorrow. So when we see how we go about it, I assure us that it will be very simple for us, every one of us. So today, this is what we call it a day. Thank you guys for joining the class. Have a great day. Thank you. Thank you so much. Thank you. Bye.